So in this video, we are going to go over displacement and velocity. So whenever we talk about displacement, we basically just mean distance. So if you're standing on the football field, you start out at the 20-yard line and you manage to get to the 80-yard line before being tackled, it's pretty apparent that your distance is just 60 yards, 80 minus 20. So we're now going to reframe that in terms of displacement. So displacement equals change in position, which equals final position minus initial or starting position. So the symbols delta x, which is displacement, equals x sub f, which is final position, minus x sub I, which is initial position. So now we reframe this. We would solve this problem as delta x is equal to, so the final position is right here, it was 80, minus initial position, 20. 80 minus 20 is equal to 60. Delta x equals to 60. There's a displacement of 60 yards. So what if instead you had started at the 80-yard line and then gone to the 20-yard line? So let's look at that. Delta x would now, you have an initial position of 80. That's right here. 80 yards. Final position of 20. 20 yards minus 80. So delta x displacement is equal to negative 60 yards. So we're now going to transition. Well, one other point I'll make. Displacement does not necessarily always equal distance, because if you went from the 20, then the 80, then back to the 20, you've traveled 60 both ways. So you've gone 120 yards. But since you started here, went here, and then came back, you started and ended at the same spot. So your displacement in this situation would be 20 minus 20 equals 0. So while it's helpful to think of distance when you think of displacement, remember the two are not exactly equal. So a related topic is velocity. So velocity is very similar to speed, except it has a direction. So we're going to define average velocity as total displacement divided by the time interval. So average velocity, change in position, or displacement over time interval. So symbolically, you'll write v sub av equals delta x over delta t, which just equals change in position over change in time. So this is x sub f minus x sub I for final position minus initial position over t sub f minus t sub I, which is ending time minus initial time. So let us look at a problem with velocity. So if you are driving to your friend's house, you're going 370 kilometers west. Takes you 5 hours. We're going to write it as the average velocity equal to delta x over delta t. Change in position, displacement over change in time or time interval. Displacement 370 kilometers. Change in time was 5 hours. So we're going to divide it to 370 by 5. 74 kilometers per hour in the west direction. So let's look at a variation of this. So during a foot race, Andrea runs 6 meters per second to the east. What will be her displacement after 2 seconds? So we have the velocity, average velocity. We want to find displacement. Let's take another look at that equation. Average velocity equals displacement over time interval. But this time we want the displacement. So I'm going to go ahead and manipulate this equation so that I move all delta t over here and just get displacement on one side. I want to multiply both sides of this equation by delta t. So I move it over. Now delta t on this side crosses out, and we have change in time times velocity average equals displacement. So we know the change in time was 2 seconds. We multiply it by average velocity was 6 meters per second. Seconds ends up crossing out. So it's hard to see that here. Seconds are crossed out. And you just get 12 meters. To give you a better idea how the cross out would work. You have 2 seconds being multiplied by 6 meters divided by seconds. Now you can see how the seconds cross out and you are left with just 12 meters. So as you can see, displacement is directly related to velocity, and velocity, average velocity, is related to displacement and the time interval. Anytime you're given 2 of these quantities, you can always find a third. And you can always use algebra to manipulate these variables directly, or you can use algebra after you've already plugged in the numbers in order to find what you're looking for. So now I'll make one other note on the subject of displacement velocity. So we're going to oftentimes look at things graphically. Here's a graph. Sometimes we're going to graph position versus time, which will give us an idea of the displacement over time. Looking at a position versus time graph, also, whenever it's a constant velocity, allows you to look at the graph and tell the velocity by taking the slope. So I'll say that again. If you plot the position versus time graph and you draw the line, you can derive the average velocity just by taking the slope of the line. So as a reminder, slope measures rise over run, or the change in vertical coordinates, or the change in horizontal coordinates. It turns out to just give you average velocity. So looking at this graph, you can see that the rise is up, at least at this point, it's 4. The run is also 4. So by rise divided by run, 4 divided by 4, or 1. Here, the rise is 8, the run is 8. So once again, 8 divided by 8 equals 1. So this is an object at a constant velocity of 1 meter per second. And we were able to tell that just by looking at the slope. That about sums it up for displacement and velocity.